Welcome friends, my name is Satyajeet Sahu and I welcome you to this champion series of our BYJU'S Exam Prep official YouTube channel. Okay, and today we'll be seeing hydrographs. Okay, so hydrographs is a very important topic for your upcoming GATE examination. So we'll be exploring hydrographs. So let me welcome our participants. Welcome Mr. Ankit, Mr. Bipul and Ms. Survi. So warm welcome to all. So let us start the session, okay, on these hydrographs. Before that, a short introduction about myself. So my name is Satyajeet Sahu. I have done my BTech and MTech both from IIT Kharagpur, and I have been selected into many of the PSUs. And I have also given the ESC examination. I've got a very good score in the ESC interview, that is 140, which is considered one of the highest in the country. Okay, and I have been teaching all across the nation, more than 15 states. Okay, I am associated with Byjus for the last 2 years. Okay, so my lectures are available on the Byjus Exam Prep app. You can always download the app and see my lectures, and also they're available on this particular YouTube channel. Okay, so I teach all the civil engineering subjects and also teach general studies. So good evening Juhi, good evening Dia, good evening Ans. Let us start the session. Okay, let us start the session. So this is a catchment. Okay, this is a catchment. You might have heard this word catchment. This is what? A catchment, or I can say a catchment area. So in a catchment area like this, suppose you have a catchment area like this. Okay, you see this is a one area. This is one area. This is one catchment area. In this catchment area, whenever there is rainfall, okay, you can see that there is rainfall in the catchment area. Yes. So whenever there is rainfall in this catchment area, okay, so what will happen? There will be flow. You can see there is flow of the, rainwater, right? It is flow of the rainwater. Okay, and they all join. Okay, I am representing the rainwater with this blue drops, okay, or arrows. Okay, so when they join, okay, they form what? Streams. They form what? Streams. You can see different streams are formed like this. So different streams are formed like this. Now all these streams, they merge into the main stream of a catchment area. They all merge into what? The main stream of a catchment area. Yes, this is what? The main stream of the catchment area, and all the streams, okay, which are originating due to the rainfall, they merge into this main stream. Okay, so in this diagram you can also see that this is the mainstream. This is what? The mainstream. Yes. So wherever there is rainfall, you can see that all are forming what? Small streams. Yes. And eventually you see all are what? Merging into this mainstream. Yes, merging into this mainstream. Now you can see this is a outlet. This is known as what? The outlet of the catchment area. This is known as what? The outlet of the catchment area. Yes, and from this outlet the water will eventually drain out. The water will eventually drain out. Yes, so now if you are plotting the discharge from this outlet, yes, since there is flow of water, okay, due to what? Due to the rainfall, right? Due to the rainfall there is flow of water in that particular catchment, and in the catchment all the small stream, they are combining to form what? The main stream. Okay, combine to form the mainstream. So in the outlet you will get some discharge, right? This discharge due to what? Due to the streams formed due to the rainfall, right? Now if you are plotting what? You are plotting the discharge at this outlet. Yes, the discharge Q at the outlet, right? Discharge Q at the outlet, okay, versus time. That is known as what? Tell me in the comment section. That is known as what? If you are plotting the discharge at the outlet versus time, that is known as what? Tell me. That is known as what? Tell me. If you are plotting the discharge at the outlet of a catchment area versus time, we'll call that as what? What is that is called? That is known as a hydrograph as told by Karthikeya. Others, they have to know, they know this term, yes. That known as hydrograph. So if I ask you what is an hydrograph, the hydrograph is a plot between what? The hydrograph is a plot between the discharge Q. Discharge Q will be in meter cube per second mostly, yes. Discharge Q at the outlet of a catchment area versus time. Okay, versus time. Okay, so you can see that we will get some curve, plot like this, right? Some plot like this. Okay, means what? Initially, I can say there will be some existing flow. Okay, before the rainfall also, there will be some existing flow, and that flow is known as base flow. So before the rain, there is some base flow occurring. So when the rainfall starts at t is equal to 0, the rainfall starts, what will happen? The discharge will increase, right? The discharge will increase. This will increase, right? And then we'll get a peak, right? And the rainfall stops before the peak, and then the rainfall, the flow will decrease and eventually again become what? Eventually again become equal to what? The base flow, amount of base flow. So if I repeat whatever I have told again, that initially we have a base flow, yes, and when the rainfall starts, okay, the discharge will increase, right? You can see the discharge is increasing. Now the rainfall stops, then what will happen? It will attain a peak value. It will attain a peak value, and then again it will decrease and become equal to what? Your base flow. So I can say his will be what? This will be the, again, the base flow. This is what? The base flow. Okay. Now this particular plot is known as what? A flood hydrograph. It is known as what? The flood or storm hydrograph. Known as what? Flood or storm hydrograph. Now we will come across another hydrograph term that is known as what? The direct runoff hydrograph. Known as what? The direct runoff hydrograph. Now what is this direct runoff hydrograph? Let us understand. See, this base flow was existing without the rainfall also, right? Without the rainfall also, this base flow, I can say, okay, this base flow, if I draw a straight line like this, yes, this base flow was existing before the rainfall also. Before the rainfall also, the base flow was existing, right? Now if you remove this base flow, what you are getting? You are getting this portion, right? If you remove this base flow, you are getting what? You are getting this portion, and this portion is only purely due to what? Purely due to the rainfall. Purely due to the rainfall. And that is known as what? The direct runoff hydrograph, also known as DRH. In short, we write it as what? DRH, direct runoff hydrograph. Direct runoff hydrograph. Okay. Now I can say this direct runoff hydrograph, how we are getting? Very simple. We are having the flood hydrograph, yes, we are having the flood hydrograph, and we are subtracting what? We are subtracting the base flow. We are subtracting the base flow to get what? Your direct runoff hydrograph. So by this time, everybody know, sorry, here I wrote gram, it is hydrograph actually. Okay, so everyone knows what is a flood or storm hydrograph and what is the DRH, and how we get the DRH from the flood hydrograph. Okay. Now there are some other names for this direct runoff hydrograph. Let us see those names. Okay. What are the names? This DRH, direct runoff hydrograph, resulting only due to the rainfall, right? Other names are, first name is direct runoff hydrograph, direct runoff hydrograph. Okay. The other names are your effective rainfall hydrograph. It is also known as effective rainfall hydrograph. Okay. It is also known as the rainfall excess hydrograph. These three terms are same. Now many people get confused between all these three terms. Okay. But these three terms are same. Which three terms? The three terms, namely direct runoff, effective rainfall and rainfall excess. They are same thing. They are the same thing. So now you will not get confused between these three terms. Direct runoff is same as effective rainfall. It is same as rainfall excess. Okay. Now coming back to our hydrograph. Okay. If I take this area, okay, this area. What is this area? This area I can say is the area under DRH. It is what? The area under direct runoff hydrograph. Now you see this area is what? Area under curve, right? Yes. This area is what? The area under DRH. It is what? It is the area under curve, right? Area under curve. Now what will be the unit of this area under curve? You can see here we have discharge and here we have what? Time, right? So it will be discharge will be how much? Meter cube per second. Taking the area, na, meter cube per second, and then what? This time is second, suppose. So I'm getting what? Meter cube. Meter cube is unit of what? Meter cube is unit of volume. So very important thing we got from here, that the area under DRH, which is also the area under curve of this direct runoff hydrograph, gives us the direct runoff volume. Gives us what? Direct runoff volume. Let me, explain to you in a different manner. See, this is our catchment area. This is our catchment area, right? And this is our mainstream, yes? And this is our outlet, right? So from here, discharge Q is coming out. And we are plotting that Q, right? We are plotting that Q, right? Now, if you take a big container, it's an imaginative container. You should not take a big container, okay? Suppose it's an imaginative container like this, right? And you allow the water to accumulate from this outlet, right? You allow the water to accumulate in this outlet. So what you will do? With this Q, if you multiply the time for which you allow to accumulate, you will get what? The volume of water accumulated, right? Yes or no? You will get the volume of water accumulated, right? Indirectly what I am saying, that if it is raining in this catchment area, and all this water is draining into this mainstream, and then you are taking what? Q into T, the discharge into time. The discharge into time is what? The discharge into time is nothing but what? Area under DRH, direct runoff hydrograph, is giving me what? The volume of water, right? The volume of water from direct runoff, right? The volume of water from what? Direct runoff from this catchment. So, what I got? What conclusion I got? The conclusion I got is the area under DRH. The area under DRH is equal to the runoff volume. Is equal to what? The runoff volume. Yes, runoff volume. Now, what we saw? Area under DRH. Yes, area under DRH. Now runoff volume. You see, this runoff volume. This volume can be what? This runoff volume. What I can say about this runoff volume? Can I say this runoff volume will be equal to what? The height of water accumulated here, right? The height of water accumulated here. This H. Yes. This H into what? The catchment area, yes. Into what? The catchment area, yes. And this height of water accumulated will be known as what? The runoff depth. Known as what? This H known as what? The runoff depth. It will be known as the runoff depth. Understood? Very good. So from here, what I can say is that the area under DRH is equal to what? It is equal to the runoff volume, yes, and this runoff volume is equal to what? The runoff depth into what? Catchment area. Into what? The catchment area. Now, can you tell me what are the other names for this runoff depth? I just told you some time before. Can you tell me what are the other names for this runoff depth? which will be in centimeter or mm or meter. Tell me, what are the other names for this runoff depth? Let me see what people are answering. I just told some time before the other names of runoff or direct runoff. What are the other names of direct runoff? Tell me please. I am waiting for your answer. What are the other names of, I can write down runoff depth, I am writing what? Direct runoff depth. So what are the other names? Tell me. I just told you some time before. Tell me. I am waiting for answer. Hope you're writing the notes. If you're writing the notes, you'll get the answer. If you're writing the notes, you'll get the answer. Yes, 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 very good. Effective rainfall. Yes, effective rainfall. Very good. Effective rainfall. Other name? Other name? Other name? I've written. Another name I wrote. Yes, rainfall excess. Only Kartikeya is reading. What are others doing? Sleeping in the class. Yes, rainfall excess, right? I just told you, right? Sometime before I just told you. Direct runoff is actually equal to the effective rainfall, actually equal to what? Rainfall excess, right? So they will ask questions based on this. They will ask questions based on this. This is a very important formula for your GATE examination. This is a very important formula for your GATE examination. Yes, the area under DRH, the area under DRH is equal to the runoff depth into the catchment area. It's a very important formula. Suppose we have, discharge versus time. And suppose the hydrograph is a triangular shape. Yes, it can be any shape. Suppose the hydrograph is triangular shape like this. It is triangular shape. Yes. So I can say this is what? This is your peak discharge. What I can say about this? This is your peak discharge. Okay. This is your peak discharge. So this height will also be equal to what? The peak discharge, right? This height will be equal to what? The peak discharge, QP suppose. QP. This is suppose QP, the peak discharge. Okay. Now suppose this is the base time. Means what? The base time of this particular hydrograph. Yes. So if they give you this curve, okay, they give you this curve. That means what? Your QP is known, TV is known, base time. This is what? The base time or base period I can say, or base time better. And this is the peak discharge. This is what? The peak discharge. Now tell me, I will tell you only, the area of this direct runoff hydrograph will be what? The area under DRH. The area under DRH will be equal to how much? It will be equal to half the peak discharge, which acts as what? The height. It acts as height into what? The base time. Yes. And this will be equal to, suppose the catchment area is A. So A into what? Runoff depth, suppose that is, or that is excess rainfall or rainfall excess, that is ER suppose. Effective rainfall or excess rainfall, right? So ER. Now tell me, using this relationship, they can frame questions. They can frame questions. How? Very simple. You see, they can give you the catchment area. They can give you the effective rainfall, right? They can give you the base period, yes, or base time. They might ask you to find out what? The peak discharge. Yes, this might be a question, right? Suppose I'm giving you data, okay? I'm telling that the catchment area is X kilometer square. It is what? X kilometer square. Okay. The rainfall excess is 2 centimeter. It is what? 2 centimeter. Okay. And then it is mentioned that base time, the base time of hydrograph is 15 hours. Okay. And it's a triangular shape. Okay. Triangular shape is given. Okay. Triangular shape is given. And the peak discharge of this direct runoff hydrograph is given as 90 meter cube per second. So can you find the X for me? Let us see how many solve this question for me. Find X for me. Find X. Okay, find out. No. Base time is not the duration of rainfall. I will clear the doubt. Okay. See, when we plot, okay, when you plot this, see, this is the base time, right? This is the base time. Okay. The rainfall will stop somewhere here before the peak. The rainfall period will be somewhere before the peak. Now this is a very common, doubt, but I will clear. You see, if you remember, when it rains outside, when the rain stops, you go outside, the water is still flowing, right? Yes? Means what I'm trying to say is that the water takes more time to flow than the rainfall period, right? Yes? Or I can say the water flow don't stop when the rainfall stops, right? It continues after the rainfall stops. Yes? So the rainfall period and base period are different. Okay? So now answer this question. Be careful about the units. Be careful about the units for this question. Be careful about the units. I will also solve for you. Okay. Same formula means what? Use the concept area under DRH. Area under DRH is equal to what? The effective rainfall into your catchment area. Effective rainfall into catchment area. Okay. Now try to match the units. You see, area under DRH, it is a triangular, hydrograph. The area will be half peak discharge into this base time. Okay. Now see what happens. Peak discharge is 90. This base time is given 15 hours. Is given how much? 15 hours. So I'll convert these hours into seconds. Why? Because this discharge in meter cube per second. So I'll convert into what? Seconds. So the second get cancelled. So 15 hours, 1 hour having 60 minutes and then 1 minute having 60 seconds. Now this is in meter cube. Now this will be equal to the catchment area, which is in kilometer square. So kilometer square will be how much? 10 to the power 4 meter square, right? Not 4, 10 to the power 6 meter square, right? And then the rainfall excess is 2. So 2 into 10 to the power minus 2 meter. So this is what? Meter square and this is meter. So I get in what? Meter cube. So I converted everything in such a way that I am getting what? I am getting in meter cube. Okay. How? Very simple. This was kilometer square. I converted into your meter square. 10 to the power 6. Yes. And then this was 2 centimeter. I converted into what? Into meter. 10 to the power minus 2. Okay. And then this was meter cube per second. So I multiplied this 15 into what? 16 to get what? Second. So meter cube per second to second what? I got meter cube. Others find out the answer. Ankit is telling 243. Others please tell the answer. Let us see what is the answer for this. I will also solve. Others please tell the answer. Others are not solving. Why not solving? Solve. Yes, I am getting your X as from this equation 121.5 kilometer square. Others also please confirm this value. I am also getting the same answer. Others also please confirm the answer. Have some water. Very good, very good. So that means you can see that from this equation they can frame many questions, right? You see, from this equation they can frame many questions, right? There are 4 parameters: peak, discharge, then the time, best time, and then area of the catchment and effective rainfall. So out of these 4 parameters, they can give 3 parameters and ask the 4th one, right? Yes, so they can frame many questions from this particular equation. Now this is when the hydrograph is what? Hydrograph is triangular. Now if the hydrograph is discrete, discrete means what? I'll explain what is discrete. Discrete means what? Suppose at different intervals I am seeing the discharges. Okay, I am seeing the discharges. Suppose, and all these intervals are same. Suppose this interval is, suppose I am telling, Suppose I am giving this interval as I, then 2I, then 3I, okay, 4I, 5I. So you can see that the time interval is same, that is I. Yes, this is time, okay. The time interval is same, suppose I. And I'm getting, this discharge value something like this. At I am getting some value, then at 2I am getting some value, okay. 3I am getting some value, and 4I am getting some value. Yes, 5I am getting some other value, okay, sorry. 6 I am getting some other value like this. 7 I am getting some other value like this I am getting. Okay, now you see that they are not forming any pattern, right? They are not forming any pattern. So what I will do, I will join them. I will join them like this. Okay, I will join them like this. Yes, I will join them like this. Here I will get some value. Suppose I'm getting this value. So these are what? Discrete data points. These are not forming any pattern like a triangular or rectangular. Nothing is formed. Okay, nothing is formed. So they are not forming any pattern. Okay, forming any pattern. Suppose like this, other 8I, and suppose this is the end. So this is also a DRH, right? This is also a DRH, yes. And you can see that these are the different data points. Different data points. Okay. I'll call that as different ordinates. I'll call this what? Different ordinates. So this is suppose O1, right? And this is suppose O2, and this is suppose your O3, right? And this is suppose the O4, and this is suppose O5, this is suppose O6, and this is suppose O7. These are what? The different, your ordinates. Now, if I want to use the same concept and find out what? Suppose catchment area is given, I find out what? The effective rainfall. I'll use the same thing, right? What? Area under DRH is equal to what? Area under DRH is equal to, I can say, your effective rainfall into what? Into your catchment area. Yes, I will use this. Now, how to find out the area under DRH? You can see that this particular area which you are seeing is a combination of different triangles and trapezoids, right? Now, what will be the area of this? You see, all these intervals are having what? I as the base, right? So I can say the area for this one will be what? It will be half of I into O1, right? Yes. What is the area of this? This is a trapezoid. How we find out the area of trapezoid? That is half sum of parallel side is what? O1 plus O2 into the distance between them. That is I, right? I can say I'll find out this area as half O2 plus O3 into I. Yes. Like this I will find out. This one will be what? This one will be half, yes, O3 plus O4 into I. Yes. Like this I will keep on finding. Yes. And this last one will be what? Half O7 into I. Now, if I take the total area, that will become the area under DRH, right? So can I say this area under DRH will be, you see, half of I into O1 plus half of O1 plus O2 into I plus dot plus half into O7 into I. Now you see this, if I take your half and I common, can you see that this O1 is coming 2 times? Yes, over here. Even the O2 will also come 2 times, right? You see here O2 2 times, yes, and O3 also 2 times, yes. Like this, every ordinate will come 2 times, right? So what I can write down here? 2 into O1 plus 2 into O2 plus dot what? 2 into O7. Yes. So I can take this as what? This 2 will get cancelled, right? And I get the summation of all ordinates into the interval, right? So the area under the area under DRH becomes what? The summation of all the ordinates into this interval. Understood how to find out the area under DRH for such a case? Yes? Everybody understood how we are finding the area under DRH for such a case? Yes, it is clear, right? How we do? Very simple. You take the sum of all the ordinates and multiply this interval, okay? the interval in which you have taken the data. The interval, right? It can be 2 hour, 1 hour, whatever, right? Understood? Very simple. Very simple. And then you can do the things. Suppose we do a question here. We'll do a question, then we'll understand. Okay, we do a question here. Here you can see that the ordinates of a flood hydrograph is given. Yes, the ordinates of a flood hydrograph is given. Yes, and the base flow is given. Okay, it is asked to find out the effective rainfall and the area of catchment is given. So from this it is clear that I am going to use the relationship. Which relationship? That area under DRH, area under DRH is equal to what? The effective rainfall into the catchment area. Easy. Now the catchment area is given. Yes. So if I can find out the area under DRH, okay, I can find out the effective rainfall. Now first of all, tell me these are the ordinates of the flood hydrograph given. What should be my first step? Tell me. What should be my first step? Mention in the comment section. What should be my first step? I'll wait for your answer. What will be my first step in this? Tell me. What will be my first step? Please tell me. Okay. The flood hydrograph ordinates are given. Tell me. Okay. Come on, others. Everyone. Okay. So we have to find out the effective rainfall. So what should be our first step? Yes, our first step should be to find out what? The ordinates of your DRH. And how to find out the ordinates of DRH? Tell me. How to find out the ordinates of DRH? You are telling that you have to find out the ordinates of DRH. How I will find out the ordinates of DRH? Tell me. How I will find out the ordinates of DRH? Yes, Ankit, we have to do the sum. But that sum of ordinates is for what? Is for your direct run of hydrograph, right? It is for direct run of hydrograph, right? So that means what? I have to convert first this flood hydrograph data into what? Direct run of hydrograph by subtracting what? The base flow. And the base flow is given as 5 meter cube per second. So I can say this is what? The flood hydrograph. I'll subtract 5, right? I'll subtract 5 to get what? The direct run of hydrograph ordinates. Yes, the direct run of hydrograph ordinates. What are they? 0, yes, then 10, then 35, okay, then 75, then 55, then 45, then 20, then 10, and then 0. These are the ordinates of the direct run of hydrograph. Very simple, very straightforward, right? Very simple, very straightforward. Next, if I want to use the data, I have to get the summation of ordinates of what? The DRH of DRH. Tell me what is the sum of all the ordinates of the DRH. Please tell me. Please add all of them and tell me the summation of ordinates of the DRH. Because here, not a fixed shape is formed. Yes. So tell me the sum of the ordinates of the DRH. Please mention in the comment section. 250. Okay, let us see. 0 plus 10 is 10. 45. Then 120. 175. And then 180 and 220. 240 and 10, you're 250. You're getting how much? 250 meter cube per second. 250 meter cube per second. Now what I will do? Okay. Now what I will do? This is 250 meter cube per second. You can see that this is the plot, right? This is the plot. You see, this is 0. Yes. This is 10. Yes. You see here I am getting how much? Here I am getting 35. Yes. Then I am getting 75. Yes. And then I'm getting here how much? 75. Next was what? 55. Then 45. Yes. This I'm getting as 55, right? And then 45. Yes. And then I am getting 20. Yes. And then I'm getting 10 and then 0. Yes. So this is what? This is the plot of the hydrograph. And the area how I got? Just I added what? All the ordinates. And this is the DRH, by the way, right? This is the DRH, right? I just added all the ordinates. I added all the ordinates. Easy. I got what? The summation of ordinates is 250. Now this interval is how much? This interval is 12 hours, right? You see? This interval is 12 hours, right? This interval is 12 hours. So if I want to find out the area under DRH, the area under DRH, yes, that will be equal to summation of ordinate. That is how much? Your 250, but that is in 250 meter cube per second. and this time is in hours. So what I will do? 12 hours, 60 minutes and 60 seconds. I convert it into seconds. So what I'll get? I'll get this much in what? This much in what? In meter cube. Now this I will equate to what? The effective rainfall, that is in centimeter. So I have to multiply into -2 to convert into what? Meter. And then the area was given how much? It was given, what was the area given? The area given was 450 kilometer square. So 450 kilometer square is what? 450 into per 6 meter square. So from here tell me what is the effective rainfall in centimeter. What is the effective rainfall in centimeter? Please mention in the comment section. What is the effective rainfall in centimeter? 2.4. 2.4 centimeter. Okay. Very nice, very good. Very nice, very good. So everybody understood this thing, right? Everybody understood this thing. Easy, right? Easy. Yes. So if I want to find out the effective rainfall, very easy. Okay. You take the area under your direct run hydrograph, and that is what? Effective rainfall into catchment area. Very simple. So many questions are asked from this. We'll solve some. But before that, we'll go to some concept, that is what? Unit hydrograph. We'll go to a concept known as what? Unit hydrograph. Now, what is unit hydrograph? Yes, unit hydrograph is a hydrograph. It's a direct run of hydrograph. It's a direct run of hydrograph, okay, whose excess rainfall, okay, whose excess rainfall, or I can say excess rainfall, or I can say what? Effective rainfall, okay, whose excess rainfall or effective rainfall is 1 centimeter. Unit depth, I can say what? 1 centimeter. It is what? 1 centimeter. The excess rainfall of a unit hydrograph is what? 1 centimeter. Okay. So it is denoted by what? It is denoted by d hour hydrograph. Denoted as what? D hour hydrograph. What does that mean? D hour hydrograph. This is the period of rainfall which resulted in what? Your 1 centimeter excess rainfall. Okay, this is the period of rainfall. So when I write 4 hour unit hydrograph, what is the meaning of this? The meaning for this is 4 hour unit hydrograph means the rainfall period is 4 hour and the excess rainfall is what? 1 centimeter. Okay. Now students get confused. They think that the base time is 4 hour. No, na. The base time won't be 4. Okay. Tell me, the base time will be less than D or more than D? Tell me. If this is the period of rainfall, tell me the base time will be more than D or less than D? Tell me from your common sense. From your common sense, tell me it is more than D or less than D? Tell me. It will be more than D, right? It will be more than D, because we discussed that the base time of the hydrograph will be obviously more than the period of rainfall. Why? Because we know that from our real experiences also, we know that when it stops raining, still the runoff is continuing outside, right? It takes some time for all the water to drain out, right? Even after the rainfall has stopped. So therefore, never get confused that what? The D hour unit hydrograph, what is that D? D is not the base time, okay? D is not the base time. It is what? It is the period of rainfall. It is what? Period of rainfall. And what is the excess rainfall for a unit hydrograph? It is 1 centimeter. It is what? 1 centimeter. Now, what is the use of this unit hydrograph? What is the use of this unit hydrograph? Okay, we will see. Now, first of all, how to obtain a unit hydrograph? How to obtain a unit hydrograph? We'll see that first, and then we'll see the use also. How to obtain a unit hydrograph? Very simple. Okay. Like this example only. This is the example. We saw this is the example, right? This is what? A DRH of excess rainfall. Excess rainfall how much? 2.4 centimeter, right? Yes. This was a DRH of excess rainfall 2.4 centimeter. Yes. And suppose I am telling that the rainfall period was suppose 8 hours. It was 8 hours. Okay. So now we will apply what? Unitary method. We'll apply what? Unitary method. How? You see, this is the DRH for 2.4 centimeter excess rainfall. And these are the coordinates. These are the coordinates when the excess rainfall is what? 2.4 centimeter. Now for a unit hydrograph, the excess rainfall is how much? It is 1 centimeter. For a unit hydrograph, the excess rainfall is 1 centimeter. So what I can say? I can say that for 2.4 centimeter, the coordinates are this. Yes. So for 1 centimeter, we'll apply unitary method. The coordinates will be what? This coordinates divided by what? Divided by the excess rainfall. Divided by excess rainfall. Now tell me from this, what will be the coordinate or ordinate of your unit hydrograph of duration 8 hours at 12 hours? Tell me, what will be the ordinate? Tell me, what will be the ordinate of your unit hydrograph? Tell me, what will be the ordinate of unit hydrograph? Yes, just divided by 2.4. I'll just divide by what? 2.4. So I'll get how much? I'll get some 4.17. I'll get some what? 4.17. Now what will be the ordinate at 24 hours? Tell me. What will be the ordinate at 24 hours? Tell me. What will be the ordinate for 24 hours? Yes, we can find out. 35 divided by 2.5. Okay. So similarly, what I can do, I can divide, right? So this is the direct runoff hydrograph which we have got. Okay. To get the unit hydrograph, what I will do, I will just divide by the excess rainfall. So here I will get 0 for the 0 one. Then I will get how much? 4.17. I'm getting how much? 4.17. The next one is what? The next one will be 35 divided by 2.4. I am finding out and writing down. Okay. So this is 14.58, right? Then 75 by 2.4. Yes. That is your 31.25. 31.25. And then 55 divided by 2.4. I am getting 22.92. Yes. Then 45 divided by 2.4. I am getting 18.75. Yes. And then 20 divided by your 2.4. I am getting 8.33. Yes. Then again that 4.17 and again 0. So this is what? These are the unit, you can say ordinates of what? The unit hydrograph. So everybody understood how we are getting the unit hydrograph from a direct runoff hydrograph? Very easy. We'll get a unit hydrograph from a direct runoff hydrograph by dividing it what? With the excess rainfall or effective rainfall. Easy. Easy. Everybody understood? Easy. Easy. So you can see I am getting something like this. You see? You see? This was my what? DRH. You see? This was my DRH, right? This was my DRH. Yes, this was my DRH. Yes, this was 75, the peak. It was 75. Okay, this was 35. Yes, this was 10, right? This was 55. This was 45, right? This was 20, and this was here 10, right? 10 and then 0, right? And then we divided it by what? The DRH got divided by what? The excess rainfall to get what? The unit hydrograph. Yes. So here I got the peak of the unit hydrograph. How much? 31.25. Others I am not writing. You can always write. Understood? So this one is what? This one is the unit hydrograph, and this one was the direct runoff hydrograph. So everybody is clear now, right? Everybody is absolutely clear how to get this. Let us write some steps, right? Let us write some steps. Let's write some steps how to find out. So steps, and we'll solve some questions also. Steps to find your unit hydrograph from flood hydrograph. Steps to find out what? Unit hydrograph, okay, from flood hydrograph. Okay, so let us see what are the steps. Okay, Let us see what are the steps to find out what? Unit hydrograph from flood hydrograph. Then we'll solve some questions also. Okay. The steps are very important. See, it is very important that we go for a systematic study. You always do a haphazard study, but it doesn't help. Always we should do what? Systematic study. Yes. So the first step is what? From the flood hydrograph, and you can see your notes also that we have done the same thing. From the flood hydrograph, we subtracted what? The base flow, right? So when we subtracted the base flow, we got what? The direct runoff hydrograph. The second step is to find out what? The effective rainfall, right? How we got the effective rainfall? That was, we got the area under DRH, right? First we got what? The area under DRH. We got the area under DRH divided by what? The area under DRH divided by the catchment area, right? Yes. Divided by what? The catchment area gave me the effective rainfall, right? Because the effective rainfall into the catchment area was the area of DRH. So we use this and find out what? The effective rainfall. We got what? The effective rainfall. And then what was the third step? The third step was to get the unit hydrograph. How? From the DRH, you divide what? The effective rainfall. Everybody is clear about these three steps or not? Tell me. Any doubt you have, please ask. Everybody is clear about these three steps or not? We followed these three steps only. Yes. First, remember, from flood hydrograph, we got the DRH. Then we got the area under DRH. How we got this area under DRH? The summation of ordinates into what? The interval, right? Okay. If we have discrete, if we have triangular shape, then we can take what? Half. If it is triangular, we can take half peak discharge into base time, right? Okay. This is the two ways we find out what? The area under the direct runoff hydrograph. Then we divided what? The catchment area to get what? The effective rainfall, and then the unit hydrograph I am getting how? By DRH divided by the effective rainfall. Clear? Everybody is clear? Very straightforward. Follow the steps. See, we had the understanding, yes. We developed the understanding, but along with the understanding, it's also important to be systematic in your approach. Always be systematic, okay? Very good. Next thing, see. The next thing is to find out what? Steps. I write down steps to find what? The reverse. What? Reverse is what? The flood hydrograph from unit hydrograph, okay? The flood hydrograph from unit hydrograph. Yes, the flood hydrograph from unit hydrograph. You see, earlier what we did? From the unit hydrograph to, means from I can say flood hydrograph, I was getting the unit hydrograph, right? Here what I am doing? From the unit hydrograph, I am getting the flood hydrograph. I can say just the reverse, right? So these two types of questions are hit in the GATE examination. These two types of questions are hit in your GATE examination. What are the steps? The first step is, what you will do? The first step will be what? The unit hydrograph into the effective rainfall will give me what? It will give me what? The DRH. Now, for that you need to find out the effective rainfall, right? How you can find out the effective rainfall? Very easy. You see, for the unit hydrograph is given, right? Unit hydrograph is given. For the unit hydrograph also, you can find out the area under unit hydrograph, right? The area under unit hydrograph. Okay? No, we can't do. Here we can't do. The effective rainfall will be given to us. No, we can't do here. The effective rainfall or the rainfall excess will be given to us. It will be given, don't worry. So when the effective rainfall is given, okay, the first step is what? You find out the effective rainfall, if it is given or not. Okay, so they will give the effective rainfall. So first step is to find out the effective rainfall, which will be mostly given. Now once they give the effective rainfall, second step is what? You multiply this effective rainfall with what? The ordinates of the unit hydrograph. That will give me what? That will give me the direct runoff hydrograph. Very easy. And then to this direct runoff hydrograph, you add what? Your base flow. You add what? Your base flow to get what? You get the flood hydrograph. Everybody understood? It is just the reverse. See, if you see now, it is just the reverse, right? It is just the reverse step of what we have seen. Just the reverse step of what we have seen before, right? You see, here from flood hydrograph, I subtracted the base flow to get DRH. Here I am doing what? You see here? Here I am doing what? Sorry, here I am doing what? DRH, I am adding the base flow to get what? Flood hydrograph. Just the reverse. Just the reverse. Okay. Here you see, to find out the unit hydrograph, I am dividing the direct runoff hydrograph with the effective rainfall. Whereas here, to get the direct runoff, I am multiplying the effective rainfall with the unit hydrograph. Okay. Now there is another way of finding the effective rainfall. That is very easy. What is that? That is by if the infiltration rate or loss rate is given. What is the meaning of this? I'll make you understand. You see, suppose this is our earth surface. Now it is raining. It is raining. It is raining, right? Now see, the thing which will form the runoff will be which flows on the surface, right? This will form the runoff, right? This will form the runoff. Yes. And this is, I can say, the excess rainfall. This I can say is the excess rainfall. Or this I can say is what? The effective rainfall also. This I can say is what? The effective rainfall also. Now, suppose this is the rainfall, actual rainfall falling. Okay, this is the actual rainfall falling. Okay, now some will percolate also. Some, rainfall will percolate the earth surface. This is the ground level. Some rainfall will percolate the earth surface. So I can say these are the losses. The losses. Now this loss rate is known as phi. That is what? The infiltration rate. That is what? The infiltration rate. Okay, the infiltration rate. And the infiltration rate is in centimeter per hour, or I can say mm per hour. It is what? How much depth is percolating per hour, or per, I can say, the mm or centimeter per hour. Yes. Now, this rainfall is in centimeter. Yes. This excess rainfall is centimeter. Yes. Excess rainfall is effective rainfall, because that is actually becoming the runoff. That is accessible, right? The other is percolating. Yes. So from here I can say the effective rainfall. From here I can say the effective rainfall is actually equal to what? The actual rainfall minus the losses. Now see, this is in centimeter, this is in centimeter, right? So this infiltration is in what? Phi is in what? It is in centimeter per hour. So to get in centimeter, what I will do? I'll multiply the time of rainfall, right? I will multiply what? The time of rainfall. The time of rainfall, right? So I'll get what? I will get the losses in centimeter. Yes. So from here also you can find out what? The effective rainfall if this data is given to us. If the phi is given to us, we can find out this thing also. Let us solve some questions now. So everybody is clear now, these two steps and this effective rainfall. Yes. Everybody is clear, right? So these two steps and effective rainfall, right? Okay. So solve this question. I am giving this time. Come on. You solve this question. I am giving you some time. Okay. I'll drink water by that time. Okay. I'll drink water. And it is becoming a little hot, so I'll switch off the light also. Let us see how I'm looking. So it is a little dark. Okay, a little dark. Okay. So please solve the question. Then I'll switch on the light when the when the answer is there. Solve the question. So we'll be covering many topics like this before the GATE exam in a very efficient manner. You can see that in less than 1 hour we have completed such an important thing, right? In less than 1 hour we have completed such an important thing, right? So we'll be studying like this in a very effective manner. Okay, I will teach the theory also and solve numericals also. आप तभी चलेंगे 150 others. Please follow the steps. Follow the steps. You see, we have to find out the peak of to our unit hydrograph. Yes. And the flood hydrograph is given. So it is what? It is unit hydrograph from flood hydrograph. Follow the steps. Not taking so much time. This 2 hours is what? Is the time of rainfall, right? The duration of rainfall. This I can say is the rainfall. You have to find out first what? The effective rainfall. How much time you are taking, man and woman both? Okay, got the answer. Time to switch on the lights. Lights are back. Okay, so I can say from here, first step is what? First step is to find out what? The effective rainfall. Now, effective rainfall is what? It is the rainfall. It is the rainfall minus in loss rate or infiltration rate into time of rainfall. So this is what? 2 centimeter into what? 0.4 into 2 hours of rainfall. It's giving how much? 1.2 centimeter, right? 1.2 centimeter. Now you see, this is the flood hydrograph, right? This is the flood hydrograph. Now we will get what? We will get the direct runoff hydrograph. Okay. The see, when I am telling flood hydrograph, I will get the direct runoff. I am getting the ordinate, right? So this will be how much? The flood minus the base, which is how much? 20. So I am getting how much? 180 meter cube per second. So what will be the peak of the unit hydrograph? I can say, see, the peak of direct runoff is the peak of flood minus base flow. So I can say the peak of unit hydrograph will be how much? The peak of direct runoff hydrograph divided by the effective rainfall, giving me how much? 150 meter cube per second. Very easy. Now next question. Next question. Solve this question. Come on. This is also the same thing, similar thing. It is what? Similar thing. Unit hydrograph from, no, it's not the same thing. A little different. Okay, little different. Different. First try to solve, then I will solve. Okay. First I am giving you some time to solve, then I will solve. First you solve. I will sleep. I will wait for your answer. Please you try first. First you try, then I will solve. I'll sleep till the time you solve the question. Take your time, take your time. I am writing the hint. See, your unit hydrograph is actually what? The unit hydrograph is actually a direct runoff hydrograph. Yes. So this formula, area under DRH is equal to ER into catchment area. So the effective rainfall for a unit hydrograph is how much? 1 centimeter. So I can use this relationship, right? Yes. So try to use this relationship and give me the peak ordinate of unit hydrograph. Okay. This was a little different. Okay. So other data is not required till now. Other data is not required till now. Okay. Use this and give me what? The peak ordinate. Let us see first who finds out the answer. See, unit hydrograph is a triangular shape with base hours how much? 15 hours. And peak occurs at 5 hours. Means something like this. Something like this. Right. This is the unit hydrograph given, right? This is the hydrograph given, right? This is 15 hours, right? And the peak occurs at 5 hours. Okay. It is asked to find out what? This peak. Suppose this is QP. Now how to find out? Tell me what's the answer? Huh? Now this is also a DRH, right? You see, unit hydrograph is also a DRH. So I'll use the concept what? Area under DRH. I'll use the concept what? Area under DRH or UH here will be called excess rainfall. That is how much? For a unit hydrograph, excess rainfall is 1 centimeter into catchment area. Catchment area is given how much? It is given to us as 50 kilometer square. Given to us as 50 kilometer square. Okay. Now area under this unit hydrograph will be what? Half. Base is how much? 15 hours. Base is 15 hours. 15 hours is what? 15 hours is 15 into 60 minutes, 60 seconds. And this QP will be in meter cube per second, right? So this second get cancelled. Yes, I get in meter cube. Now this is equal to 1 centimeter is 1 into power minus 2 and 50 kilometer square is 50 into power 6, sorry. So from here I can get the peak discharge. Understood how we got the peak discharge? Yes, we're getting 18.52. So it's another important thing which I wanted to explain here. It is another important thing I wanted to explain here that the area under DRH is equal to effective rainfall into the catchment area is also applicable for a unit hydrograph because unit hydrograph is also a direct run of hydrograph with a excess rainfall of 1 centimeter. Easy. Easy, understood everyone? This I got what? The peak discharge of the unit hydrograph. They are asking us the peak of the flood. Can you find out now? The phi index is given, base flow is given. Now can you find out? Can you find out? Okay? Can you find out the peak of your, I will frame here, the question is here, okay? A storm of depth 5.5 centimeter. That is what the rainfall, right? This is the rainfall, okay? And duration 2 hours. This duration, okay, 1 second. Yeah, duration is 1 hour. Okay, duration is how much? 1 hour. The peak ordinate of the hydrograph. Nothing is mentioned means what? We have to find out the peak of the flood hydrograph. Now follow the steps and give me the answer. The peak of flood hydrograph. See, we know what? We know the peak of your unit hydrograph, right? That is how much? That is equal to 18.52. So can you find out from this peak of the unit hydrograph the peak of the flood? We know the steps, right? I have explained the steps. I have explained to the steps. Tell me, what's the answer? What is the peak of, this is the, we can say peak of your unit hydrograph. Give me the peak of your flood hydrograph. Tell me. Tell me. 92.6 is for the direct runoff. You forgot to add the base flow. Yes, there is a base flow also, right? There is a base flow also, right? Okay. See, first of all, you will get the DRH peak. How you get the DRH peak? The DRH peak is unit hydrograph peak into effective rainfall. By the way, effective rainfall is how much? It is the rainfall minus phi index is given how much? phi index is given 0.5 centimeter per hour, and this is the period of rainfall. So I can say 5.5 minus 0.5 giving me how much? 5 centimeter. This is what the excess rainfall. Very good. So from here I get how much? You see this, how much I get? 18.52 into 5. I'm getting how much? 92.6 meter cube per second. Very easy. So for the flood, how much I will get? For the flood, the DRH peak plus base. The DRH peak plus base. So this is equal to 92.6 plus 10, that is equal to how much? 102.6 meter cube per second. Understood everyone? How we solve this question? I'll explain to you from starting. You see, a unit hydrograph was given to us, right? A unit hydrograph was given to us, right? And then the rainfall was given to us and the phi was given to us. Rainfall and phi and the time of the rainfall was given to us. So what I did? First I got my effective rainfall. That was how much? The rainfall occurring minus phi into t. But it is not sufficient. I needed this peak. Yes. How I got? This base was 15 hours, right? So what I did? Half into this peak. Yes. Half into this peak. Okay. Half into this peak into the time, that is 15 hours. I converted into what? Seconds. This become equal to what? This is the unit hydrograph. So excess rainfall is 1 centimeter. Try to understand. This excess rainfall which we got 5 centimeter, it is for the DRH. Yes, it is for the DRH. For UH it is how much? It is 1 centimeter only. So this is 1 centimeter into what? Catchment area. We know that. From that I got what? This QP. And this I got how much? This I got 18.52. Then I knew the effective rainfall of the DRH. So what I did? I just used what? Unitary method. Yes, I can say that. Then I got the DRH peak. Yes. Then I got what? The DRH peak. Something like this, right? I got the DRH from the unit hydrograph. And how I get the DRH from unit hydrograph? I just multiplied what? The effective rainfall. And this I got how much? This I got how much? This I got as 92.6. This I got how much? 92.6. Yes, very easy, very easy. Then what I did? Then I added the base flow. I added the base flow. Base flow was how much? 10, right? Base flow was 10. So 10 got added everywhere, right? So 10 got added everywhere, right? Something like this. And this became what? This became the flood hydrograph. This became what? This became the flood hydrograph. And after this, the base flow will continue like this. Understood? And this value is how much? This value is 102.6. So everybody got an understanding of this particular thing, right? Everybody got an understanding of this particular thing. Now, the next thing. The next thing is, you might have heard now. You might have heard this, right? A unit hydrograph is given. How to get the peak of another unit hydrograph. Or I can say how to get another unit hydrograph from an existing unit hydrograph. It's very easy. I will just tell you. So here what is given? A 3-hour unit hydrograph is given, right? A 3-hour unit hydrograph is given. What's the meaning of this? The meaning of this is the duration of rainfall is how much? 3 hours. And the excess rainfall is 1 centimeter. Is the meaning of this? The duration is 3 hours, excess rainfall is what? Your 1 centimeter. Now what you do, if you repeat it again, if you repeat this rainfall again, then what will happen? D 3 hours, 1 centimeter, then you repeat it after 3 hours. You repeat after what? You repeat after 3 hours, right? Or I can say lag by 3 hours. After means what? Lag by 3 hours. So again 3 hours rainfall and excess rainfall is what? 1 centimeter. Excess rainfall is what? 1 centimeter. If you add these two, you will get what? A total rainfall of 6 hours, right? If you add these two, you will get what? A total rainfall of 6 hours. Okay, total duration of 6 hours. And effective rainfall how much? 2 centimeter or not? Everybody understood this point or not? Tell me. Everybody understood this point or not? Again I will tell that first you allowed rainfall of 3 hours for 1 centimeter, right? Rainfall of 3 hours, 1 centimeter. Then after that 3 hours, you repeat that rainfall. You repeat that rainfall means what? You are lagging the second rainfall by 3 hours, right? Because first the 3 hours will get complete and then the second 3 hours will start. Yes, yes. So what is the total rainfall time? That becomes 6 hours, and then here 1 centimeter, here 1 centimeter, I got what? 2 centimeter rainfall. Let us see how to do it. You see here. So this is the 3 hour unit hydrograph is given. Okay. So what I will do? For first 3 hours, I will do this. Okay. So this is happening for the, you can say this is the first 3 hour rainfall. Then the second 3 hour rainfall. Then the second 3 hour rainfall will start after 3 hours. It will start after 3 hours. So this will become 0 now. And after this, it will continue 0, 20, 45, right? So you can see that we are repeating the rainfall with a lag of how much? 3 hours. With a lag of 3 hours. So this is what I can say, 3 hour unit hydrograph with a lag of how much? Lag of 3 hours. Now what you do? You add both of them. You add both of them. So what you will get? You will get a 6 hour 2 centimeter hydrograph. This means what? 0, you are adding, you're getting 20, then 65, yes, then 105, then 108, okay, then 64, and then 16, and then 0. Everybody understood this or not? Everybody understood. Now this is what? 6 hour 2 centimeter. If I want 6 hour 1 centimeter, right? Or I will call this as what? 6 hour unit hydrograph. What I will do? I will just divide this thing by 2 now. I will just divide this thing by 2 because 6 hour 2 centimeter is this one. So 6 hour 1 centimeter will be what? Just divide by 2. So this is 0, 10, 32.5, right? Then 52.5, right? Then 54, then your 32, then 8 and 0. So this is the way we get what? This is the way we get a 6 hour unit hydrograph from where? From a 3 hour unit hydrograph. So they can ask a question like this, you see. They can ask a question like this, like it is asked that 3 hour unit hydrograph is given. They're asking what? The peak of 6 hour unit hydrograph. So what you did from this 3 hour, you prepared the 6 hour unit hydrograph. And from here, can I say this is the peak? Can I say this is the peak? Yes or no? Everybody understood this thing. Any doubt you have, please tell me. Otherwise, I will go to the next thing. Any doubt how we got this 3 hour, from the 3 hour I got the 6 hour unit hydrograph. Any doubt you have, please tell. If it is not there, you write down clear. So we'll move to the next thing. Clear? Very good, very good, very good. Now see, what they can do is that in this they will add little masala. Okay, in this they will add some masala. What is that masala? See, what is that masala? You see, the 3 hour unit hydrograph is given. Okay, 3 hour unit hydrograph is given. Okay, now they will ask you a rainfall of effective rainfall, a rainfall of effective rainfall 3 centimeter, or say suppose 3.5 centimeter occurred for 6 hour, find peak discharge if base flow is 15 meter cube per second. Okay, now how to solve this question? Very easy. You see, first of all, it is a 6 hour rainfall. Yes, and this peak discharge means what? This peak discharge, they're asking for the flood, right? Because the base flow is given, means they're asking for the flood. That means what they're asking? They're asking the peak of the flood. Now how we get the peak of the flood? That is equal to the peak of the DRH. Okay, peak of the DRH into what? Effective rainfall. Now how we get the peak of the DRH? That is equal to peak of the unit hydrograph. Sorry. This is plus base flow. Plus base flow. Yes. Now how we get the peak of the DRH, that is peak of the unit hydrograph into what? Effective rainfall. Yes. Now for this thing to apply, the rainfall duration should be same, right? Yes. The DRH duration, yes, the DRH duration and the unit hydrograph duration should be same, right? But here you see the rainfall occurred for 6 hours, whereas the unit hydrograph duration is how much? 3 hours. So I cannot do this thing. Understood everybody or not? Why I cannot do this thing, everybody understood or not? Because you see, this is 6 hours. Yes. I can do all this business. Flood is equal to DRH into this and DRH equal to this when all the durations are same. When all the durations are same. Durations are not same. So what I will do? I will convert this 3 hour unit hydrograph to 6 hour unit hydrograph. Now once I convert, then what happens? You see the DRH, flood, unit hydrograph, everyone has 6 hour duration or not? Yes, yes. So what? Now how to solve this question? Now I converted the 3 hour to 6 hour, right? I converted the 3 hour to 6 hour. Yes, why I converted? Because the DRH is given of having duration 6 hour. That is the case, right? Therefore I converted. Now once I converted the unit hydrograph from 3 hour to 6 hour, I am getting this peak. Now I can do that business, right? Now I can do that business. So what will be the peak of DRH? Tell me. The peak of DRH will be the peak of unit hydrograph, that is 54 into what? Your effective rainfall, that is how much? 3.5. So how much I'm getting this? I'm getting a value of 54 into 3.5, that is 189, okay? And then if I want to find out the peak of flood, okay, the peak of flood, that is how much? For the DRH, okay, the peak of DRH plus the base flow, that is how much? 204 meter cube per second. Everybody understood this question or not? Everybody understood this question or not, right? So I can use all these things. Flood is equal to DRH and then plus base flow, and DRH equal to unit hydrograph plus your effective rainfall only when the rainfall duration is same for the unit hydrograph and what? And that of the DRH. Understood? Very good. So now I will give a question for you as homework. Okay, so I'll give a question for you as homework. Okay, so 4 hour unit hydrograph is given. You have to find out the peak of the 12 hour unit hydrograph. This is your homework. Okay, this is your homework. Okay, this is your homework first of all. Okay, and the second part will be, this is the first part. The second part is find the peak of a rainfall of effective rainfall or rainfall excess as 1.5 centimeter and duration 12 hours and duration 12 hours. Base flow is given 5. Base flow is given 5 meter cube per second. 5 meter cube per second. I will help you in this. I'll just help you in this. I'll just help you in this. Okay, you see. The 4 hour unit hydrograph is given. Now what I will do? How many times I will repeat this? Tell me. How many times I will repeat this? Because from 4 hour unit hydrograph, I want a 12 hour unit hydrograph. So tell me how many times I will repeat this. Tell me. How many times I will repeat this? I'll repeat 3 times, right? I'll repeat 3 times. So I can say this is the first one, yes, then the second one, and then the third one, right? I'll repeat the 4 hour unit hydrograph 3 times, yes. But here there is a catch. You see, these time intervals are not 4 hours. These time intervals are what? 2 hours. So when you go for the second repetition, the second one, it will start from where? It will start from this one, not from this one. Why? Because only when the first 4 hour rainfall is complete, then only the second 4 hour rainfall will start. Na? Yes. So here will be the 0, 16, 30, 50, 36 and 0. Everybody understood this concept or not? Yes, because the data is taken every 2 hours. Sometimes people don't see this and commit mistakes. Sometimes people don't see this and commit mistakes. What they do is they think that okay, we have to just lag it 1. No, 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 no. You see here, we have to lag by 4 hours. If the data was given like this, suppose this is 0, 4, 8, 12, 16 and 20. Suppose data is given like this. Suppose it is given like this. Then the aim is to what? Lag by 4 hours. Then you would have started from here. Yes or no? Then you would have started from here because the second rainfall will start after 4 hours. So suppose this is 4, then it started from here. Yes or no? Yes, very easy. But here what happened? Here you can see that the 4 hour is over here, right? So when this first 4 hour rainfall is complete, then only the second one will start. So from 0, 16, 30, 50, 36 and 0. And then the third one will start again after 4 hours. So in total what? After 8 hours. So it will start from here, right? The third will start when the second 4 hour unit hydrograph is also complete. Means what? 4 hour, 4 hour. 8 hour is complete. So it will start from here. 0, 16, 30, 50, 36 and 0. So if you combine now all this is all are 1 centimeter. So total will be 12 hour 3 centimeter. How much I get? If I add all 0, 16, 30, 66, 66, 66, 66, then 50, then 36, then 0. So if I want 12 hour unit hydrograph, I'll do what? I'll divide this by 3, right? I'll divide this by 3. Yes. So I'll get 0, then 5.33, then 10. Then I get a constant value for some time, 22, 22, 22, 22. Then it is decreased, it becomes what? 16.7, yes. And then I can say 12 and then 0. So I can say we get a flat portion, right? Because we're getting, constant peak. We're getting a constant kind of thing. Means what? The curve will be something like this. The curve will be something like this. Yes, I'll get a constant portion like this. 22 is repeated, okay, like this. Understood? But 22 is the peak, right? I can say 22 is the peak. 22 is the peak of the 12 hour unit hydrograph. I actually solved the question. I actually solved the question also, right? Okay, no homework then. Understood this one? Yes, this is the peak. Understood? Yes. So now at least you do this for me. At least you do this for me. I got the peak of the 12 hour unit hydrograph. That is what? 22 meter cube per second. Now at least to solve this for me. At least no homework. Tell me at least to solve this for me. What's the answer? Tell me. What is the peak of the rainfall? Means basically they're asking what? The peak of the flood. The peak of the flood. Tell me how much is this? That is equal to, I can say, the peak of the DRH, right? The peak of the DRH plus base flow. With base flow 38, okay. This I will get what? The peak of the unit hydrograph into 1.5. So this will be how much? 22 into 1.5. Give me how much? 33, right? So 33 plus 5, that is what? 38 meter cube per second. So you can see such kind of questions they can ask in the examination. Yes. So we have completed substantial portion of the hydrographs. Actually, yes or no? We have completed a substantial portion of the hydrographs. Only one thing is remaining that I will not teach. That you can see in our app. If you read our app, you will find that thing. What I didn't teach? What I didn't teach? I didn't teach S curves. Okay? I didn't teach S curves. What is S curves? You see, when I am finding 4 hour to 12 hour, right? This is basically what? This is basically from a lesser duration to higher duration unit hydrograph I am finding. Now how to find out from 12 hour a 5 hour, okay? Or suppose from 5 hour to 7 hour, okay? So how to find out these things? This is using what? Your S curves. That I have not taught, but you can find out in the app. It is available in the app. But apart from that, we have solved and understood many of the important concepts for your hydrographs. Hope you enjoyed today's lecture. Okay. So coming to tomorrow. Tomorrow also I will take an interesting topic on what? Stability analysis of your gravity dam. Yes, in irrigation engineering. You see, in irrigation engineering, if you see, the most important topic is what? The water requirement of crops. That I have already taken in one particular video where I solved the previous question of irrigation. I will give you the link tomorrow. Okay, I'll give you the link tomorrow. Okay. So I'm taking, topics which, normally are not taken. Okay. Normally, I think it's 9 p.m., but it might get shifted. So you can note down the timing will be 6:30 p.m. Okay. The timing will be 6:30 p.m. The timing will be showing 9 p.m. I will shift it to 6:30 p.m. Okay. This is the shifting will be there because of some technical things, some technical, I can say, things will be going on in the night in the studio. So 6:30 p.m. tomorrow. So I will take what? See, water requirement of crops is the most important topic. Okay, that I have taken in one video. I will share the link tomorrow. I'll share the link tomorrow. But the stability analysis of dam, very less people take, right? Yes, and many students have doubt in in this stability analysis of gravity dam. Yes, and questions are also asked from this. Okay, so tomorrow we'll be seeing what? Stability analysis of gravity dam. So stay tuned. We will have more lectures also. Okay, so we have more lectures also. So in the future also we'll have a lot of lectures. Okay, so stay tuned. Okay, so thank you very much. We will meet tomorrow. I will just call our technical team. Okay, I'll just call our technical team that will end the session. Thank you very much, and tomorrow please come, and more sessions will be coming up. More sessions will be coming up in the future. So please stay tuned and subscribe to the channel. Okay, the channel, and you can go to the link, the description link. You will find out the Telegram group. In Telegram group, not my Telegram group, the official Byjus Exam Prep Telegram group. I don't have a Telegram group. Okay, but in the official Telegram group, all the details of the classes are shared. Also, the PDF of these lectures are also shared in that. Okay, so please. Okay, thank you very much. Bye bye, tata. Tomorrow 6:30 p.m. we will meet. Bye. Thank you everyone.